Hey guys, welcome to DevOps School. Kubernetes is one of the most popular technology in cloud computing as of today. Learning Kubernetes is essential for any DevOps professional, and one of the most in-demand certification is Kubernetes administration. In this session and in this series, we are going to learn various aspects of Kubernetes administration, which will help you to prepare for the Certified Kubernetes Administration exam or CK exam. This series is divided into 20 parts, therefore subscribe to our channel and follow the playlist for complete understanding.
Okay, so today is the first session of Kubernetes. So we will try to understand more about that, what is a Kubernetes and how it is helping out. So as part of the discussion, we're going to discuss about how Kubernetes can bring health, wealth, and happiness. So yes, health to you, uh, health to the one who's using Kubernetes, to the employees, and wealth to the organization, and happiness for both. So how Kubernetes can bring health, wealth, and happiness. Apart from that, also we are going to discuss what is Kubernetes, what is a Kubernetes architecture, how can we install, working with pod, working with the deployments, and many more. So these are the topics we will try to cover today and tomorrow. So the question is, what is Kubernetes? Okay. So in order to understand what is Kubernetes, these are the four building blocks. These are the four important questions which we need to understand. Where did it come from? What does it do? What does the name mean? And why do we have it? And many more. So these are the questions I'm going to answer now. So yes, Kubernetes is born in Google, and Kubernetes got donated to CNCF in 2014 as part of the open source initiative. Kubernetes is written in Gogolang, so you can find out the source code at github.com, the URL which you can see on the slides. Again, the website for the Kubernetes is kubernetes.io. There are Slack channels also and various meetups groups, official and non-officials, using that you can be a participant in Kubernetes initiative. Now the next question is, where did it come from? So if you see this slide, here the Kubernetes DNA is matching with Borg and Omega. Yes. So what is Borg and what is Omega? We do not have exact, detailed about the Borg and Omega, but because of this is a proprietary tool on which Google's platform is running. And you can imagine such a vast platform, Google, which is running, which is never be down, which is up 24/7, scalability, availability, and all this thing has been taken care of for, but not the millions of users, billions of users, and billions of transaction happens every second. To look at the kind of load and the kind of infrastructure which has been handled by Borg and Omega, and so we say DNA is matching. That means Kubernetes also has the ability to manage such a large infrastructure, something similar to Borg and Omega. So we say, okay, so Kubernetes is donated by Google to CNCF, and same time Kubernetes DNA is matching with Borg and Omega. So we can say Kubernetes is somewhere correlated to the Borg and Omega, and overall Kubernetes has the same features as Borg and Omega has it. So this is the one. What is the meaning of Kubernetes? So meaning of the Kubernetes is, it is a Greek word, and that is called helmsman. The helmsman, the person who steers a ship. So basically Kubernetes is a kind of tool. If you try to correlate with the helmsman, so helmsman is a person who steers the ship. Now the size of ship, it can be fishing boat also, smaller, very smaller, and it can be a big size aircraft carrier as well. Now both the ship, if you look at this, is been steered by a person who's being called as a helmsman. So basically only one person can control the entire ship, so no matter if the ship is very big or very small. So same way Kubernetes can also manage your entire production operations, run container orchestrations alone, and the infrastructure size, it may be small or it may be big. So that is the definition of Kubernetes. In short, we call it KS. So ultimately, yes, Kubernetes born in Google, donated to CNCF in 2014, open source. First release has happened in the 1.0 in July 2015, written Gogolang, and some of the officials handle and things like that. You can find it. So the question is what and why we need a Kubernetes? Why do we need this Kubernetes? And Kubernetes will help you to solve two problems. Kubernetes will help you to solve the two problems. One problem is containers bring scalability challenges. Okay, containers bring scalability challenges. And second problem is we starting to view the data center as a computer. Okay, so if you have work with Docker, right? And I believe all of you have already prepared with the Docker. You have spent so much of time understanding the Docker world, because that is one of the important prerequisite for this session. So yes, if you have understood the Docker very well, it has a scalability challenges. And the scalability challenges is very simple. You cannot create and manage the container more than what the host can handle. So if you want to have the more containers, if you want to manage more containers across the host, then Docker is unable to do that. Containers technology runtime environment is unable to do that. So we need some tool which we call it a containers orchestration tool. How can we manage containers across the nodes, multiple nodes? Okay, so that is one of the problems which we are trying to solve through the Kubernetes. And another thing is we're starting to view the data center as a one computer. So we need a tool which should look at all the data centers. Let's say data centers, you have so much of CPU, so much of RAM, so much of storage, multiple operating system, multiple servers. So similar to the Docker, whatever the CPU, RAM, and storage you add to the one host, Docker view as a one unit. So same way, tools, we should look at, we should see your data center as a one computer. So we need a tools like that. And here Kubernetes can manage it. So Kubernetes can view the entire data center as a one computer, and same time Kubernetes can help you to orchestrate the containers out of one node. So it can manage the multiple nodes, multiple machines where the containers are running, and it will Kubernetes can help you to serve that as a one computer. Okay, so in this session, when you are in this session, you need to understand the difference between the pets versus cattle. So if you look at the pets versus cattle business, remember here, in the pets things, what if you have a pets, you have one or two pets, you take care of them, you shower them, you take to the doctor if something goes wrong, you feed them, and you personally take care of it. All of your pets, you love them, you care them, and spend time with them. But in a cattle business, someone who's very into the cattle business, he's worrying about the number of let's say if you're in cattle business and you have to produce 1,000 liters of milk every day, right? So that is the client expectations. You have to deliver the 1,000 liters of milk every day. So now the question is, if some of the cattle is not performing and which is compromising the delivery of the 1,000 liters of milk every day, so what you're going to do? You're going to replace the cattle. You're going to replace the cattle rather than getting emotional with the cattle and trying to fix it and compromise your 1,000 liters of milk every day. You're not going to do that. So you are going to replace the cattle, and then so your 1,000 liters of milk delivery every day is not compromised. So yes, you are in a cattle business now. The pets business, something like it was a Docker. You were playing with the Docker, you were taking care of it, you were, seeing that how the application runs inside the container, the images, this, that, and all. But today you are in a cattle business. You are in a business where you are in a production environment. You are going to make sure that your applications, if the thousands of instances is required, it has to be running. If some of the nodes which is not able to accomplish that task, so you're going to replace that and with a new one, and then that is how. So you are in a cattle business. Now who can help you to get this cattle business done? Kubernetes. How? We're going to understand that. So this is the mindset which you have to set. So ultimately, if you take it up in a broader perspective, what is Kubernetes? So Kubernetes is a container orchestrated tool. It helps you to workload placement. Workload placement means it helps you to manage the workload of your infrastructure, running application running infrastructure. It also helps you to infrastructure abstraction. It also helps you to manage the desired state. So whatever you want to you want to implement, the desired state is managed by the Kubernetes. Okay, it brings lots of benefit as well. It brings speed of the deployments. In the demo section you would see how the deployment can be speed up and things like that. It is also ability to observe the changes very quickly than before. So something which you can say, Kubernetes can help you to do that CI/CD immediate feedback also. Also it has ability to recover quickly. So your application, if it is deployed and something goes wrong, it has ability to recover quickly. If you want to do the patching, updates, and stuff like that, it can be done through Kubernetes quickly. Again, a deployment of the application to the n number of servers can be done quickly. Also, not only speed of the deployment of the application, ability to observe the changes quickly, and ability to recover the applications quickly, all this functionality. Apart from that, hide complexity in the cluster. So the complexity which you need to experience, that is not there with the Kubernetes. So these are the major benefits when you are running applications in a container and orchestrating using a Kubernetes. These are the major benefit you could get it. Okay, so Kubernetes is moving fast, so that's one of the only way which you can be up to date is to keep practicing it, because lots of changes is happening and lots of new things is coming, lots of old thing is being deprecated. So this one of the only one way you should keep getting up to into this. With that introduction, we are going to understand how Kubernetes works. What is the architecture of the Kubernetes, how Kubernetes works. So basically, so far we have discussed what is Kubernetes, where did it come from, and why do we need it. Okay, why do we need it? Now we are going to discuss about Kubernetes architecture. Before that, we'll spend 2 minutes of time of addressing the questions, whatever you have. Do you have any question?
No, not from me. Rajesh, just one question. So Kubernetes competition is Docker Swarm, is it?
Yes, Docker Swarm is a competitor product for the Kubernetes.
Okay, fine.
So now let's understand how Kubernetes can bring health, wealth, and happiness. How Kubernetes can manage such a small ship, such a small data center, and such a large data center. We're going to understand how Kubernetes can manage and orchestrate your container across the multiple nodes. How Kubernetes can help you to overcome the challenges of containers scalability. How Kubernetes can help you to fulfill your desire of production, and you should be and making you in a cattle business very efficiently. How Kubernetes can get you the speed of deployment, speed of recovery, speed of patching, and hiding all the complexity. And answer for this is hidden in the architecture. So as part of the Kubernetes architecture, we are going to discuss about a big picture view, what is masters, nodes, POS services, deployment, and many more. So now understand, let's be big picture. Kubernetes is an orchestrator for microservice app. Now, question is, what is microservice? Okay, I'm encouraging all of you to read more about the microservices. What is microservices? What is a microservices app? What are the models? What is the practices and stuff like that? But if you look at this in the today's world, if you want to do the DevOps, you want to do the CI/CD, if you want to do the immediate release, you want to do the releases in a few seconds of time frame, then we all are migrating towards the microservices app. Okay. Again, we are having one upcoming session on the microservices after the CK. So you probably want to get enrolled for the microservices also. But here, what we are discussing is how Kubernetes is an orchestrator for microservices app. So now, if you look at this, here we have a ground, football ground, and we have a manager and we have a team. Now, if you look at this, in order to understand how Kubernetes is an orchestrator for the microservices app, let's see that this stuff. Now we have multiple team members, we have a manager, we have a football ground. Now, if all this player is going to play on the football ground, and if you think what could be the objective of these players, the objective of these players is it something like to make a goal or something else? Most of the people believe the objective of the teams to make a goal. So if the objective of each player to make a goal, then we all will be near to the goal post. Look at this. This is the scenario. We all will be near to the goal post, and that is how we used to play in our childhood also. Right? We wanted to make a goal. We used to be near to a goal post, shouting on each other, saying that give me the ball, I'll make a goal and stuff like that. So this is how, if you have an objective to make a goal, then this will be the kind of pictures which you see. All the players will be around the goal post. But actually, that's not objective. To make a goal is not at all an objective. For any winning team, the objective is to coordinate well. Okay, so now that is where this one person comes into this picture, and that is called manager, that is called coach, that is called master. And manager says, coach says, listen, I know all of your capability. I know what can you do, what you cannot do. And you need to hear me out. You need to follow me. You need to do the same thing which I ask for. And if you do not obey, then I will keep you out of this ground. So you will not be a part of this game at all. So that is the power of manager, coach, and masters. The moment the manager, coach, and masters comes, they align the team as per their qualifications. They align a team members as per their skill set. I mean the what is it, talent. So someone is very good in defense, someone is very good in attack, and each and every one is being instructed whom you are supposed to communicate, like nearest player and stuff like that. So now objective has changed. Earlier the objective was, each player, the objective was to make a goal, but now each player's objective to coordinate with each other. Now how it has happened? Because of manager has come, coach has come, master has come. So we need some manager in our data center also. How? We'll discuss in a little bit. But here what has happened, now the objective is to move a ball from one player to another player faster than moving yourself. Do not run, make the ball running. Coordinate well. So those team who coordinates well, they will win, because if you coordinate well, ball will move faster, and there are one or two players near to the goal post whose primary responsibility to make a goal, maybe whose primary responsibility to do the front end. So now this is the kind of football football game strategy, soccer game strategy is being played out. So coordination is important, where the manager, coach, and master is important. Everyone has to follow manager, coach, and master. If you look at the data center, okay, nowadays, if you look at the data centers, we have different kind of apps running. Okay, this is your player in your football ground. Some of the apps running with the microservices of HTTPS. Some of them are login registration and stuff like that. Some of that are backend MySQL. Some of them are load balancers. Some of them are database object store. Some of them are searches. Some of them are log. So different kind of service here. These service has a special qualities similar to what qualities we had with the player. So different kind of services is being there in your data centers. All these are microservices. Now the question is, who will control all these microservices when these microservices are running in your containers? Okay, remember earlier we were running in the physical box, then we migrated to the virtual box. Now we are running application, the compute devices become a container. So the question is, how and who will control these services, these microservices? Because each of these services are having certain distinct qualities, certain distinct attributes, and all this need to communicate in a certain guidelines. Not everyone can talk to everyone, right? Not everyone can do everything, right? So every services has certain objective. So now the question is, who will control it? Kubernetes can do the things which can play a role of manager, coach, or master. So Kubernetes is an orchestrator for the microservices app, and Kubernetes control entire, containers orchestration and microservices. And now you see that here Kubernetes dictate, okay, load balancer is supposed to talk to HTTPS supposed to talk to searches, where you have a two HTTPS, and again searches is supposed to talk to the MySQL or whatever it is. Now, so this is the communication layers for the microservices app is been formed and controlled by Kubernetes. And if Kubernetes think you are not obeying it, so they will pluck you out of this data center. So they'll not make you available in the production. So that is the power of Kubernetes. So Kubernetes is an orchestrator for the microservices app. And again, we'll discuss and we'll see that how this is addressing all of your services, microservices. Now you look at this. This is an interesting topic here. You see, I said Kubernetes view entire data center as one computer. So that's the reason you see HTTPS node, HTTPS service you have in the node 1, and another HTTPS service you have in the node 2. But still Kubernetes control in the same way and give you the same policies. So basically both the HTTPS services, no matter whether it's in a different nodes, still talking to searches. Okay, so that is the power of Kubernetes. Using that, it can manage your microservices. It is an orchestrator for the microservices. Okay, so overall, this is architecture here. You have a Kubernetes KX cluster. We call it KX cluster. In full form, you can call it Kubernetes cluster. And in the Kubernetes cluster, you have master. Yes, master. You may have a multiple master also for HA. So one master is active at a time, but you may have a multiple master. That's the reason you see that multiple images of the master has been shown here. And master manages multiple nodes. Remember, in your data center, you don't have one computer, two computer. You may have a tens of computer, hundreds of computer. So master and the nodes are multiple. Okay, it may be one node, it may be multiple node, depends on the size of your ship, depends on the size of your data center. Okay, so here you have a master and then we have a node that is called Kubernetes cluster. And then who's giving the instruction to the master? There's some deployment package which you can see, which we create. Human being creates that deployment package. We give the instruction to this, we create a package, and this package is sent to the master, and master helps you to manage your desire. Master helps you to manage your desire. Remember Kubernetes, as I in terms of benefit discussion, I stated Kubernetes help you to manage your desire. How? So you write a package, send it to the master. Master helps you to manage the desire. How? We are going to discuss in some time. So overall, as part of the Kubernetes architecture, we have a master. You may be having masters, manages multiple nodes. It may be one node, multiple nodes, and that is being called as a Kubernetes cluster. Now, master who's in charge, nodes who do the work. And if you look at this here, from here you do the deployments to the package to the master, master which is in charge. Again, in the node you have a pod. You see, but the question is what is a pod, and which I'm going to come back on it. But node has a pod, and if you look very carefully, pod has a container. The sign which you can see, that is a sign of the container. So inside a pod there's a container, and I assume you know container very well. A container is the same container I'm talking about from Docker. Remember, Kubernetes is an orchestrator. Container orchestrated tool is a microservices orchestrated tool. So yes, and Kubernetes help you to manage a container which is running across the node. Now the container is running in the pod. Pod you can see inside a node, and node is being managed by master. We all component we will discuss in detail what is master, what is node, what is pod, and I believe containers you know very well already. Same time, what is a deployment package and how to write it. So these are the questions we are going to address in some time. So to begin with, let's understand what is master. Okay, typically we call it master is a Kubernetes control panel. Master is a Kubernetes control panel. So here you see one master can manage multiple node. A node which may be from the any variant of Linux. It can be Fedora, Ubuntu, Archie, CentOS, and many more. Okay. Master has a 4 important component. Master can be HA. So multiple master can be possible. Okay, multiple master can be possible. Now let's understand master can manage your nodes. Nodes has a pod, pod has a container, and if you look at this 2 node, each pod you may have a 1 container or you may be having multiple containers. So there are pods which you can see 2 containers. There are pods which has a 1 containers. So we will all discuss about what is pod in some time. Okay. So now let's know about the master. Master. So master has a 4 important component. Most important component of the master is API server. Again, remember, I said API server. That means API server manages the multiple API endpoint. Again, I'm repeating my lines. One of the component in Kubernetes, master, what we call it is Kube API server. And when we try to understand what is API server may have the multiple APIs which is managed by API server. In simple word, API server is managing multiple APIs endpoint. That's the reason we call it API server. Okay. Now API server is a front end to the control panel. When we say Kubernetes cluster is your what do you say is your work area, and out of the Kubernetes cluster you have a master, you have a node. So master is being called as a control panel. So basically, who's the front end of the control panel? So Kube API server is your front end of the control panel. When I say front end, that without this, there is no communication is been received or sent. Every communication of every kind internal to a cluster, again I'm repeating, every communication within a cluster or from the outside of the cluster, all the communication is being received or sent or addressed by API server. That is the reason we call it front end to the control panel. And it exposes the REST APIs, and API server always consume JSON. Okay, so for any communication to the cluster from outside, or from any communication to the cluster from within and inside, it has to be processed through API server. And now API server has a multiple API endpoint. Using that API server do the work. Okay. Second important component which you see here is cluster store. Now the question is, what is a cluster store? So cluster store is a place where we store all the information about the request and response. In a simple word, if I put it, cluster states and configuration. So remember, API server, as we know, is receiving all the request and response from outside and within a cluster. Now the question is, it requires some storage to store it. Okay, so where is going to store? So anything which you received, it's going to store in a cluster store. So basically, cluster store is a persistent storage. This is important. Cluster store is important. So cluster store is just like your database. Okay, where all the information is being about the Kubernetes clusters, application desire, and actual state, cluster state, and configuration is being stored. So this is the persistent storage. You store the cluster state and configuration, and in the back end, must be thinking how it is stored. So it uses etcd database. Okay, if you want to know more about the etcd database, it is a distributed, consistent, watchable. It stores the value in keys and value format, and this is the ultimate source of truth for your Kubernetes cluster. That means if this is lost, you lost everything. So you should be having a backup plan for it. So yes, API server is a front end which receive all the communications, and all the communication which has internally multiple API endpoints. Now, through API server, anything which is received is stored in the cluster store, is empowered by etcd. Now, if you want to study more about the etcd, please do that. It's very good for you to understand etcd architecture in a separate section. Is another tool again. So it's good to have a understanding about the etc in detail. But second important component is cluster store. Third thing is controller. Actually, it's not a controller, we call it controller manager. In picture, it's depicted as a controller, but it has to be called as a controller manager. Okay, so what is a controller manager is doing? So controller manager is the managing multiple controller. As name suggests, controller manager is managing multiple controller. Now the question is, what is controller? So controller is a program. Okay, controller is a program which runs in the loop, something like a monitoring tool. It runs on certain intervals, every 1 minute, every 2 minutes, every 3 minutes, every 5 minutes, every second. Okay, so controller is a kind of programs which runs in the loop and keep updating that status of that runtime to the controller manager. Okay, I don't know whether you're getting or not. It's just like a monitoring tool. It's like I'm just trying to help you to visualize, but exactly it's not a monitoring. So yes,
Your voice is breaking.
yes, tell me.
Rajesh, your voice is breaking.
Oh, is it? Okay.
Yeah.
Just let me check my internet connection.
This conference will now be recorded.
This recording. Okay, so I was talking about second component, which is controller manager. In picture you can see it is controller, but actually it is a controller manager. Now, as I suggested, controller manager has multiple controller. It is a controller of multiple controllers. That is the reason we call it controller manager. Now the question is, what is controller? Controller is basically some programs we runs in the loop and which keep updating the controller manager. So if you look at this diagram here, controller manager manages multiple controllers, each controllers which runs in the loop through API server and check something. What it check? So basically it check node controller, endpoint controller, namespaces controller. Basically it is a monitoring tool and it keep checking entire infrastructure whether my node is alive. My node, let's say in an infrastructure you have 10 nodes, all these 10 node is working alive or not, whether endpoint which you create, different kind of endpoint, it is alive, working or not, namespaces which we'll discuss in some time, is alive or not. So basically it's kind of monitoring tool. It keep watching everything in the loop and keep reporting to API server. Okay, why it's needed? Because remember, Kubernetes need to know what is there in my infrastructure and what is working and what is not working. Remember the game of the cattle business? If the 1,000 liters of milk has to deliver to the client, and for that, if some 1,000 liters of milk, because of the cattle is not performing well, cattle means node is not performing well, then you have to replace the cattle with some other cattle. So 1,000 liters of milk should not be compromised ever. So that is the power of controller manager. Again, in short, controller manager is controller of controllers which control node controller, endpoint controller, namespaces controller, and it always runs in the loop, watches for the changes and helps to maintain a desired state, because it will check what is your desire and it keep reporting to API server. Okay, this is something which you have in your cluster and this is not something which you have in a cluster, so you decide what you want. Okay, so it always runs in a loop. Now next component, if you see here, you have kube scheduler. So now what is the kube scheduler we will do? If you try to understand the meaning of scheduler, means scheduling the work. Scheduling the work to whom? To the nodes. But how? Through API server. Again, what happens? Scheduler keep watching API server for new pod. Now the question is pod. What is pod? We don't know. We will discuss on this. But we understand that pod is there in the nodes as part of the last image depiction on the slides. Pod is inside a node, and inside a pod you can find the container, which you know very well. Okay, so it watches API server for new pod request, and based on the request from API server, this assign work to the scheduler, assign a work to the node. Let me tell you here again, I'm telling you, scheduler assign work to the node, not doing the work. He just assign scheduling the work. And scheduler has affinity and anti-affinity. That means scheduler may assign the work to create a pod to the nodes, specific nodes, that is called affinity, and any nodes, available nodes, that is called anti-affinity. Schedulers can also follow the constraints. You can put it, resources, specifications, stuff like that, too many things. So in short, what happens, if you remember, this is called master altogether. API server, controller, cluster store, and scheduler is being called as a master. So overall, what happens? We send the package, humans send the package in a form of deployment package to API server. Understand the flow. API server is a front end for the control panel. So everything which is sent and received by the API server. It received the packet deployment package in a JSON format and store in the cluster store. Cluster store is your persistent storage powered by etcd. Now after that, remember I said Kubernetes cluster will help you to manage your desired state. So let's say you ask for 5 pod. Inside a pod you have a container, so you ask for 5 pod. That pod deployment package you send to the API server. API server store that package desired in a cluster store. Now controller will go and report to API server what view have. API server, based on the information from the controller, will manipulate. My desire is to create, let's say, 5 pod, and controller has reported 0 pod. So API server will send the request to the scheduler, saying that scheduler, please go and assign a work to the node. Scheduler again travel through the API server to the node and assign a work to the node to create 5 pod. So this is the story of master. This is called master. So in short, API server is your central, simple, RESTful, and powered by etcd. Cluster store is your not powered by etcd. API server is central, simple, RESTful, and update to the etcd. Cluster store is your persistent data stored, the value in the key and value, powered by etcd, and it is watchable. You can watch it through REST APIs. Scheduler, which is watching the API server, scheduler pods to the nodes, has some constraint in terms of resources and stuff like that. Controller manager is nothing but a controller loops. It helps you to lifestyle function and desired state, watch and update the API server and replica settings. So overall, this is the architecture what you have now. Okay, look at this. We have a master. Master is, we have a 4 component: API server, cluster store, scheduler, controller. And master is being instructed by your laptop. In a laptop, you install kubectl. Use create a format or YAML format, but API server always consumes JSON. Remember. So in your laptop, you install kubectl and you configure API server. API server store that package to the cluster store. controller which is keep reporting to API server about the state of this, whether matching or not, and then based
Rajesh?
on the calculation, scheduler assign the work to the node. See here, scheduler assign a work to the node, but node has something in which it create a pod. So we'll understand about the architecture of the node in some time, but node has a pod has a container, and this is the overall architecture. So now we understand master very well. Do you have any question? Any questions?
Rajesh, your voice was breaking. Can you please repeat this diagram once again?
Yes. So I'm repeating one more time. This is the overall architecture out of which you have a laptop. In your laptop, you install kubectl. You create a package, and in the package, you define everything. The package format, it can be JSON or YAML. Through kubectl, you send to API server. API server is a front end of the control panel. So API server receive that package in a JSON format only. After receiving the package request, that is a request, it's stored in the cluster store. After that, controller which keep running in a loop, keep updating API server the status of the cluster. Based on the reports from the controller, API server decide what number of pod should be created, which is mismatching from the cluster stored. Based on that, it assign the work to the scheduler. Scheduler go and assign the work to the node. Node has a pod has a container, which we will discuss in some time. Understand?
Yeah. Oh, what is kubectl?
kubectl is the one tool which you install in your laptop to interact with the API server of master.
So it's kind of client, right? For
The kind
master.
of utility. Yeah.
Okay. And what is package?
Package is something with deployment package. Basically, what you want to create in a cluster, that is called package. JSON, it can be in JSON format or YAML format.
Kind of configuration file, right?
Yes, kind of configuration file. What you want, what pod you want, what container you want, how many you want, all this stuff.
Okay, fine.
Sir, as first instance, when package come via kubectl to API server, then API server directly coordinate with controller or scheduler.
This all happens in the sync. So basically, the moment you request, it gets stored in the cluster store, first of all, because remember, cluster store is the only source of truth. It has to store what you have requested. Now you have desired something, human has desired something. So controller keep checking the entire cluster and keep reporting to the API server saying that, okay, this is what I found it out. So so let's say if kubectl you desire 5 pod, but out of which cluster has no pod. So they found, controller reported that there's no pod, I could find it out. So API server say to the scheduler, listen, go, because I got a request for the 5 pod, scheduler go please create a 5 pod. Now scheduler will go and talk to the node, active nodes, and say, okay, create a pod. Now scheduler will decide which node it will assign a work to. Scheduler has a functionality of affinity and anti-affinity. I said one line, if you remember, Kubernetes view entire data center as one computer. So basically, scheduler may decide any available healthy nodes to assign that work, or it may assign to the one node if you set affinity also. So like that.
Sorry, can you explain affinity and anti-affinity again, please?
Which one?
Affinity and anti-affinity.
Yes, affinity and anti-affinity. So scheduler is basically a software. Okay, scheduler is basically application in which it's a kind of rules. Which rules it suggests? Okay, the scheduler should assign a work to the node which should be having this much of CPU, this much of RAM, this much of architecture and stuff like that. So that is called affinity. So let's say in a node, remember in a cluster, Kubernetes cluster, you may have a multiple nodes. These nodes belongs to maybe Linux different version, different variant. But sometime what happens, you want to create a few pod, but the pod should be created only in RHEL, but maybe you have a Ubuntu also, CentOS also, Fedora also. So in that case, if you want to create a pod only in a dedicated node, that is called affinity. If you want to create a pod only in the node which has a certain minimum CPU and RAM, that is called affinity. Or if you do not set affinity, then scheduler may go assign this work any pod. So now you decide what kind of node you are selecting for the pod. Most of the time it is a random anti-affinity by default. That means you do not assign any specific node, but sometimes developers say no, listen, this has to be in RHEL, this has to be in a Red Hat, this has to be in this much of CPU, this has to be in this much of storage. But not all the node has all the CPU, all the RAM, all the storage, maybe. So in that case, affinity is there. You can declare those affinity in your JSON package, in your YAML package, in your laptop, and then push to the API server. Make sense?
Yes, thank you. What about the auth for API server?
Auth, yes. So auth is basically, see, not everyone can interact with API server. Remember, API server is a front end of the control panel. And if the front end of the control panel is accessible by everyone, then that will create a problem to maintain the state of the cluster, because your cluster may be inappropriately managed. So now the question is, who should be authorized to access API server? And that is been done by authentication. So there are different sort of authentication in API server which you may be enabled for your purpose. So only the right person can authenticate, right person can send the request to the API server. Let me remind you once again, API server for all the internal communication and from the external communication. So now only authorized request should be sent to API server, because once the request has been sent to API server, it is going to store in the cluster store. That is your source of the truth of all the clusters, your entire infrastructure. So it has to be authenticated, authentication enabled. In that case, yes, who authenticate? API server for any request, whether you are authorized to send a request to API server or not, is there in the API server. So again, we'll come back to the authentication and authorization module in a Kubernetes later point of the time. But yes, authentication is been done at the API server level. Got it?
Thank you. Yep.
Okay. So guys, this is the master, and we have tried to understand the master very well. We have a 4-component API server, controller, scheduler, and cluster store. With this, if you see that here, again, a different depiction of the same images in a different way, almost same. You have a REST API, scheduler, controller, API server, etcd and all, node, you have a kubelet, and again, we are going to discuss in some time. Now, the next topic is nodes, aka minions. What is nodes? Why do we call it minions? Many people call it the Kubernetes worker. Okay, so this topic I'm going to drive tomorrow, because from here I need at least 1.5 hours to discuss many things, which includes nodes, pods, and stuff like that. And I do not have that much of time. So I will wrap it up this session now itself with a few questions if you have. And then tomorrow again, we are going to connect at the same time. And tomorrow we're going to finish this discussion about the architecture of Kubernetes. So I'm going to stop the recording. So if you have any questions, you may ask.
Thanks for watching. I hope you enjoyed and learned from this video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Want to study further? Subscribe to our paid membership to get a deep dive into each and every topic. Do look out for more videos in our playlist and subscribe to our DevOps School channel and hit the bell icon to learn more. Keep learning.